for lesson 6 homeworks, we're going to work on graphing linear inequalities, and we're going to work on one of them, and it's going to eventually build into our systems writing where we graph multiple of them. So the first thing we want to do is we want to state 3 points that are in the solutions of the inequalities. So if I look at the first one, y is greater than or equal to negative 2x plus 6. So first, I'm going to graph negative 2x plus 6 as if it were just a regular equation. So I'll start, I got a y-intercept of 6, and then my slope is negative 2, so we're negative 2, down 2, right 1, down 2, right 1, and so on, until we have points at all parts of the graph. When I run out of space, then I'll go back to my y-intercept, and I'll go up 2, left 1, and so on. So now I need to take a look at a couple things here. First thing is it's greater than or equal to, which means that I'm going to have a solid line for these points. All right, anything with an or equal to gives you a solid line. And then the next piece I have to look at is this going to be a shade up or a shade down scenario? Well, I'm greater than, so in that case, I'm going to be shading everything up. It says it wants us to state 3 points that are in the solution set. Well, you can pick points that are on the line here, although I don't advise it. So I'm going to pick other points like 1, 2, 3. I'm going to pick the point 4, 2. I'm going to pick the point 2, 8. And how about 9, negative 2? Obviously, there are a bunch more you could pick, but if we're going to work on some simple ones, those are what I thought would be most easy. For the second one, we have to do a little bit of work because it's not in y equals form. So we're going to start by subtracting 2x on both sides. 4y is less than negative 2x plus 4. We'll divide everything by 4. And that gives us y is less than the negative 2 over 4 will simplify to negative 1/2 x. And then 4 divided by 4 is 1. So I have a y-intercept of 1. My slope is negative 2 over 1. So we're going to be, negative 1 over 2. So we'll be down 1, right 2, down 1, right 2, and so on. And we'll continue that pattern until we run out of space. Then we'll go back to the y-intercept. We'll go in reverse. Up 1, left 2, up 1, left 2. And so on. Now the key to this one is it is just a less than sign. So therefore we are going to end up with a dashed line that goes through all of these points. Remember, dashed lines are used when you have less than or greater than. So, and then we are less than, so we're going to be in a shade down scenario. Again, I'm going to look to grab 3 points off this graph. I'm going to grab 0, negative 8. I'll grab 1, 2, 3, 4. 1, 2, 3. So that's 4, negative 4. And then I'm going to have this point here, which is negative 7, 0. So again, you could have a lot more options. Those are just the 3 that I grabbed. For number 2, is the point 2295 a solution to the inequality negative 10x plus y is greater than 25? So let's address that first before we get to the second part. And all we're going to do, very simply, is we're just going to plug in. So negative 10 times 22 plus 95 is greater than 25. So when I do that, I get negative 220 plus 95 is greater than 25. When I add those two together, I'm going to get negative 125 is greater than 25. So the answer is no. Is the point on the graph of the inequality? Well, the answer to that is no, because, so if it were on the graph, and we don't mean in the shaded region, we mean actually on the line, negative 125 is not equal to 25. If it were to fall on the graph, that would mean that you would have the same number. You'd have 25 is greater than 25. Now, although that's not a true statement, it would still lie on the actual graph. But because we have a false statement and the numbers aren't equal, then that inequality is not going to hold true. Third one, write the inequality that represents each. So remember, we need two pieces always. We need a y-intercept and we need a slope. So if I look at my first one, we have a y-intercept of 1. And then it appears that we're going down 2, so -2, and then to the right 3. So we know we're going to be y something -2/3 x plus 1. Well, I look at it. My shading is above my line, so I make greater than. And then because it is dashed, I am not going to put the or equal to line underneath it. So we just get y is greater than -2/3 x plus 1. In the next one, I appear to have a y-intercept of 6. And then my slope looks like we are going to be down 2, so -2, and to the right 1. So I know I'm going to be y something -2x plus 6. So my shading here, although it's a very steep line, so it might be a little harder to see, the shading is down, so it is a less than sign. And then we have a solid line, so since it's solid, then we're going to add in the or equal to part. So if we look at it, we were shade down and solid. And if we go back to the first one, we were a shade up and dashed. So those are the key features that help play into what type of sign we use for these.